So if you need to watch the lesson again, you go to my website. Here's my link to my YouTube. You click on it. And you're astounded at how popular your math teacher's YouTube is. Then what you do is you look. 14 views. Yesterday's lesson already had 14 views. That's fabulous. So your class is Aagaa, whatever. And yesterday was the 15th. So that's yesterday's lesson. Okay? Look at this lesson though. This lesson has 79 views. That must have been a really good lesson. Okay. All right, any questions on how to get to the YouTube? Nope? Okay, great. Okay, so somebody asked me what the fifth row of Pascal's looks like. I don't know. I don't have any of them memorized. What I do every time is I quickly draw that triangle. Now, how did we get the numbers in that triangle? What did we do? What do you do to get the 2? What do you do to 3's? Okay, remember to get the 2, you just add the 2 in front of it. To get the 3, you add those 2. You add those 2, right? So what would the next line be? It should be really quick. What would it be? It would be 1, 7, 21, 35, 35, 21, 7. Once you get halfway to the other side, it mimics. All right, so this one was the fifth row, so that's what I needed, was this fifth row. So first thing I do is I write down the 1, the 5, the 10, the 10, the 5, and the 1. And then I take the entire first term to the fifth power, the second term to the 0. The entire first term to the fourth, the second to the first. First term to the third, second to the second. First term to the second, second to the third. First to the first, second to the fourth, and then the last term would be the first one to the 0 power and the last one to the fifth. Then I'm going to simplify. I'm going to raise these numbers inside to those powers. And then I'm going to multiply. Now you don't have to show me this step. You could go straight from here to here, and that's fine. Okay. How'd you do? All right, in a little while, we're going to play a game. And the game is kind of weird because the game makes us do stuff like this. And then the way we figure out where we go next is it'll say, for the next problem, go to the problem number that is the coefficient of the fifth term. What? What's the coefficient of the fifth term in that problem? 10. So we would go to number 10 and look at it. Or it might say, what is the opposite of the sum of all the coefficients and the constant? And we'd add up all the coefficients and the constant to the opposite of that, and that's where we'd go. Okay, so we'll get to the game in a little bit. The game is enjoyable to me. Now, first period I asked, and I said, was it fun or was it irritating? And they said, yes. It was fun and irritating.
Oh, yes.
Yes. All right, so let's look at your homework. Hopefully you used synthetic division when you were dividing by a linear binomial with a leading coefficient of 1. Because synthetic is quick. It's so quick. All right, on number 1, did you get 2x minus 5?
Yes.
And did you use synthetic?
Yes.
Yes. Even better. No? Yes? Okay. Because there's no remainder, what this means is our divisor is actually a factor of the dividend. What we're dividing by is a factor of what we're dividing into. Okay, take a look at number 2. Number 2, we had to use log division. Well, we didn't have to, but my direction said to use log division if we did not have a leading coefficient of 1. So we did not have a leading coefficient of 1, so we used log division. This answer sheet is showing we're doing the subtraction here. We change all our signs, and then we add. And did we get the same thing for number 2? Does anybody have any questions about that? Okay, you keep checking. 3, 4. Let me scroll. See if I can catch
Harris, but you
We're not, our numerator is never going to be the same degree. Our numerator will always be the same.
Right.
Yeah. So I will show you how we do that same thing. Now, my engineering yesterday, it was not
My mom's right. Oh yeah.
that is what we would do.
My mom's right.
Alright, any questions through 6? Yes, ma'am.
Number 6, I don't get like the plugging the 0 in and it didn't really work.
Okay, let's do that one and work that one out. Number 6. So number 6 was x to the 5th minus x cubed minus 3 divided by x squared minus 3. Okay, so if we're struggling at all with this, we want to make sure we're going to use those placeholders. So our dividend would look like this. We're going to put in the 0x because there's not one. Now, if this is really simple for us, remember I told you yesterday, I'm not going to make you put them in, but if you're struggling at all, I want you to put in the placeholders for the missing terms. And then everything lines up nicely. Okay, so our first thing we're going to do is we're going to take our term here, divided by this. So if we looked at this, x to the 5th divided by x squared, what does that give us? X to the 3rd. And then we multiply through. So x to the 3rd times x squared is x to the 5th. X to the 3rd times 0 is 0, x to the 4th. X to the 3rd times negative 3 is negative 3x to the 3rd. And then we're going to subtract, and we subtract, it changes our signs. Well, I don't know why I bothered there, because does 0 really have a sign? No, it's not affected by positive or negative. So that's going to cancel, there's nothing there, and this leaves us with 2x cubed. Okay, and then we'll look at this again. X squared goes into 2x cubed, and what does that give us? 2x. Alright, so since we have a trinomial here, when we bring down, we're going to bring down 3. And so when we multiply, everything will line up nicely. So 2x times x squared is 2x cubed plus 0x squared minus 6x. And then we're going to change our signs. So we get 6x minus 3 is left. So this is of lesser degree than this, so this becomes our divisor. Okay? Ooh, that's not what I meant. Alright. Now, right here, we may have looked at this and said 3x goes into this twice. But what we're really doing is we're doing this division, negative 8x divided by 3x. And do you see when we do that, the x's will cancel and we're left with 8/3 here. So when we multiply it back through, we get something a little ugly. But that'll give us a remainder of 25/3. And the 25/3, when we put it over the 3x plus 5, the 3 can go in the denominator. This gives us 25/3 left. When we have the remainder, we never want to have anything in the numerator that's of equivalent degree as the denominator. Okay, so look any questions?
This will be for number 7. I don't
Yes.
know if this would be like correct in the form of it, but would for the remainder, would 8.33 over 3x plus 5 be like the same thing?
So you took that 25 thirds and changed it to a decimal?
Yes.
We usually don't mix a decimal into a fraction.
Yeah. I'm
So-
just wondering. I know I should do
Yes.
it that way, but
What
that's
you
the same.
what you did is the same answer.
Okay.
Yes. Yes.
For number 10, why is it negative on top?
Because right here we look at the x squared and it has to go into a negative x squared. So if I did negative x squared divided by x squared, that would give me the negative 1. Okay. I will have these posted to the website if you need to look at them again. So what we're going to do today is we're going to play this game. And this game has a little bit of everything. It's got some adding and subtracting in it. It's got some expanding binomials. It has multiplying. It has dividing. It has naming binomials. It has a little bit of everything. So around the room are posted 15 different problems. Now, like number 15, it's a division problem. And it tells you to go to the problem number that is the constant of the quotient. So once we get our answer, we look at our answer, we find the constant part of the quotient, and then we'll go to that problem. Okay? So you will need a notebook paper. If you have a notebook, it might be easier because you're going to be up and about, give you something to write on. And this will help us with our review. Before I let you loose, though, I'm going to go ahead and give you your half sheet for homework. And then you can go ahead and get it in that notebook. It won't get lost.
Are we going to be doing the game as like groups?